Whole numbers can be separated into two categories, prime numbers and composite numbers. The difference between a prime number and a composite number has to do with the number of factors. Now remember that a number's factors are whole numbers that can divide evenly into that number. So let's take a look at a few examples. If we look at the number 8, we can see that 8 has 4 factors, 1, 2, 4, and 8. These are whole numbers that divide evenly into 8. Let's look at 12. 12 has quite a few factors, 1, 2, 3, 4, 6, and 12. Each of these whole numbers can divide evenly into 12. We can also see that 3 times 4 equals 12, 2 times 6 equals 12, 12 times 1 equals 12. Let's look at 20. 20 also has a lot of factors, 6 of them. The numbers 1, 2, 4, 5, 10, and 20. Now prime numbers are numbers, whole numbers, with exactly 2 factors, the number 1 and the number itself. So let's look at a few examples here. 11 is a prime number because it only has 2 factors, 1 and 11. These are the only 2 numbers that divide evenly into 11. 23 also has only 2 factors, 1 and 23. And 5 is another number with only 2 factors, the number 1 and the number 5 itself. Now, composite numbers are numbers with more than 2 factors. So in addition to the number itself and 1, a composite number has at least one more whole number that divides evenly into itself. Let's take a look at a few more examples of prime and composite numbers. 10, for example. If I look at the factors of 10, I see I've got 1, 2, 5, and 10. So I have more than 2 factors, making 10 a composite number. 7. I only have 2 numbers that can divide evenly into 7. This makes 7 a prime number. 16 has 3 factors, 1, 4, and 16, making 16 a composite number. 2 and 3 both only have 2 factors, the number itself and the number 1. So both 2 and 3 are prime numbers. And 9, our last example here, has 3 factors, 9, 1, and 3, making it a composite number. All composite numbers can be created by multiplying together a set of prime numbers. This is called prime factorization. So let's look at an example like 420. I can break 420 down into 2 of its factors, 2 and 210, but 210 is not a prime number yet, so I have to continue breaking that down. So 210 can be broken down to 2 times 105. 105 can further be broken down to 3 times 35, and 35 can be further broken down to 5 times 7. So at this furthest point here, we have a set of prime numbers, which makes up the number 420. So I can write 420 equals 2 times 2 times 3 times 5 times 7, a set of prime numbers. Prime factorization provides an easy way to find the greatest common factor and least common multiple of a set of numbers, as well as quickly tell whether 2 numbers are divisible.